So I want to go through how to use the steam tables. We're going to work a lot with these steam tables over the next few days, and it's important that you understand how to use them, especially going into future chemical engineering classes, because these are important tables that we use a lot. Steam, water, it's a common chemical that we encounter in many chemical processes, so we need to know how to work with them, especially understanding the energy and thermodynamics of steam and water. So this is taken from the appendix in the back of the book, and this is a part of the steam table that gives us the properties of steam at various temperatures and pressures. And in this case, this is saturated steam. So if we just show our little phase diagram down here, remind you, we have here a mixture region right here, and then we have a vapor and a liquid. Well, the saturated steam concerns this line right here. Again, remind you, this is a saturated liquid line, saturated vapor line. And the thing about this line, to remind you, is that once we know the temperature, we know what the pressure is. So once I specify a temperature, say this temperature, I instantly know what the pressure is, because that's the part about this line that once I know temperature, I know exactly where I am on that line. And I know all the properties about that specific point, or at least they're tabulated in this table. All this data is taken from experimental measurements, but once I define a point on this line at a given temperature, I know all the properties about it. So if I pick a point on this line, say a given temperature, I can look at the information here on the table and get all these properties. So let's just say I'm at a temperature of 39 degrees Celsius right here. Well, my pressure at the 39 degrees Celsius, wherever it is on this phase diagram, would be 0.07 bar. And then I have other information here, and let's go look at that. So right here I have, this is the specific volume of the vapor phase, this is the specific volume of the liquid phase. You'll notice the specific volume of the vapor is much bigger than the liquid, which makes sense because gases take a lot more volume than liquids, but the units here are in meters cubed per kilogram. We have the specific, the internal energy, of the liquid, internal energy of the vapor, enthalpy of the liquid, enthalpy of the vapor, entropy of the liquid and vapor, and we don't need to worry about entropy in this course, but it's there if we ever needed to use it. But in any case, we're given the liquid and the vapor properties, and if you remember back in our discussion on phases, you may recall that when we have a point here on the saturated liquid line, the corresponding point is just over here on the saturated vapor line, and it's a horizontal across here, so it's at the same temperature and pressure. So the saturated vapor and the saturated liquid are at the exact same temperature and pressure. The only difference is that when we're in this mixture region, we have a composition that has part vapor, part liquid, and we have properties for both liquid and vapor here on the steam table, and that we would use for calculating their properties. Reminder, this is our equation for calculating the enthalpy of a mixture. It's the fraction of vapor times the enthalpy of vapor plus the fraction of liquid times the enthalpy of liquid. We have similar equation for the internal energy and also for the specific volume. And remember that the relationship between XV and XL is just according to this equation here. So that's how we work with saturated saturated liquid, in this case saturated steam, where we either have, we're somewhere in between these two lines here, we might be directly on the lines or we might be somewhere in between them, but all the properties are on the saturated steam table here. So next I want to talk about the properties of superheated vapor. You recall back here looking at our phase diagram, this region right here is what we call the superheated vapor region. And once we're in the superheated vapor region, the properties of our vapor, they very much depend on the temperature and the pressure. And there is no unique value for temperature and pressure, meaning that we have to specify both temperature and pressure if we want to get the properties of our steam, our superheated vapor. Unlike saturated liquid, or our saturated steam, we only had to specify one property, meaning we either had to know the temperature or the pressure in order to look up its properties on the steam table. But for the superheated vapor, we need to specify two parameters, or in other words, we need to know the temperature and the pressure. So if you look in the back in the steam tables, you'll find that there are various pressures. So here's an example where we are looking here at 3 bar here. So this is 3 bar, and then all of this data only applies to 3 bar, and there may be parts of the steam table that have 4 bar or 5 bar or other pressures. But once I know I'm at this particular pressure, 3 bar, I just looked here on the left at various temperatures, and so I can look up the properties for, say, 200 degrees Celsius, 3 bar, and then I just read across just like on the saturated steam tables. But in this case, there's only one value for the specific volume, one value for internal energy, one value for enthalpy, and then another value for the entropy, which we're not worrying about. And that is because when we're superheated steam, we only have one phase. We're just at some point over here, and we don't have to worry about it being a mixture. And so in that case, we have all our properties. We just match up our pressure and our temperature and find out where we match to get our properties. Now, one other thing I want to point out here. Notice this is blank. Why is this blank for these values here? Well, that's because if we're at 3 bar and 100 degrees Celsius or 50 degrees Celsius, we are not a superheated vapor. We're actually a liquid. So it doesn't have any properties for the liquid on this particular table. It just leaves them blank because we cannot have a superheated vapor at 3 bar and 100 degrees Celsius. However, it does give us one little bit of information that's interesting. It tells us at the pressure of 3 bar what the saturated steam temperature is, right here, 133.522. And then it gives us some information here about this particular steam at the saturated pressure temperature. So there we have it. We're often going to have to look up values on the steam table for energies, for internal energies or enthalpies, or maybe even sometimes specific volume. But we'll use these when we're studying steam and when we're dealing with problems that involve flowing of steam and so forth. Oftentimes we need to know the enthalpy of steam and other properties, and so we look it up in the steam table. So we need to know how to use these steam tables, and we'll get plenty of good practice in class and on the problem sets. But make sure you understand how to use these steam tables.